So we move into reduction of order with non-homogeneous equations. So here is an example where we have a non-homogeneous equation because the right-hand side is not 0. So a constant is a function. So that is g of x. If that were to be 0, then it would be a homogeneous equation. And keep in mind, a non-homogeneous equation will have two solutions. One is a general solution, the other is a particular solution. To find the general solution, we need the associated homogeneous equation, which in this case would simply be y double prime minus 4y equals 0. And we know one of the solutions that is given to us is y1 e raised negative 2x. So we could use reduction of order to find the other solution. So by direct comparison to our derivation, we can see that p in this case is 0. And we know that the second solution, y2, is y1 integral e raised negative p dx divided by y1 squared dx. So we have e raised negative 2x integral e raised 0 divided by e raised negative 2x squared, which would equal to e raised negative 2x integral 1 over e raised negative 4x dx. And that would equal to integral e raised 4x dx. Upon integrating, we would have e raised negative 2x multiplied by e raised 4x over 4, and that would reduce to e raised 2x over 4. Since we have the second solution, the general solution is simply y equals c1y1 plus c2y2, a linear combination of the two solutions that we found. So y would be equal to c1 e raised negative 2x plus c2 e raised positive 2x divided by 4. Now we move on to finding the particular solution, because this is a non-homogeneous equation. So if we recall in our derivation for the reduction of order, u was y2 over y1, which would imply y2 is u times y1. And in the problem, y1 is given, which is e raised negative 2x. Our equation has y double prime, so we've got to find y2 double prime. You may ask me why. Well, if y1 is a solution, it is going to satisfy that equation that we have. And y2 is a solution, so that would also satisfy the equation that we have. So when I plug in y2, the equation should hold true. So I'm going to find y2 prime, which is u e raised negative 2x divided by negative 2 plus e raised negative 2x multiplied by u prime. That is product rule. So I made a mistake. So that has to be times negative 2. I integrated instead of differentiating. Now I could find the second derivative. y2 double prime is equal to negative 2 u negative 2 e raised negative 2x plus e raised negative 2x times u prime plus e raised negative 2x times u double prime plus u prime times e raised negative 2x. We need a little bit of simplification here, so 4u e raised negative 2x, negative 2u prime e raised 2x, plus e raised negative 2x, that's an e raised negative 2x, e double prime plus u prime e raised negative 2x. I feel like I'm missing a 2 here, so let me double check. Ah, there should be a negative 2 here. So that would end up becoming negative 2 u prime e raised negative 2x. Therefore, y2 double prime would be 4u e raised negative 2x minus 4u prime e raised negative 2x plus u raised negative 2x u double prime. So we're going to take this and plug it in our differential equation. We would end up getting 4u e raised negative 2x minus 4u prime e raised negative 2x plus e raised negative 2x u double prime minus 4 times y2. But y2 is u times y1, which is u times e raised negative 2x. And that would equal to 2, because we are moving on to the non-homogeneous part. So we would have 4u e raised negative 2x minus 4u prime e raised negative 2x plus e raised negative 2x u double prime minus 4u e raised negative 2x equals 2. Those two terms would go away, and we would have e raised negative 2x u double prime minus 4u prime e raised negative 2x equal to 2. We have e raised negative 2x in common. I could pull that out and multiply by e raised positive 2x on both sides. We'll have u double prime 4u prime equals 2 e raised 2x. And you may think at this point, oh, we did all this work and we ended up with a second order equation with the non-homogeneous part, so what is the point of even doing this? Well, there is another step. So let w equals u prime, which would imply w prime is u double prime. So I could rewrite the equation that we just solved as w prime minus 4w equals 2 e raised 2x. Now that is a first order linear DE. And we know that we have several methods to find the solution to a first order DE. Unfortunately, that this is not a problem that can be done with separable equations, method of separability. So we've got to use the method with the integrating factor. So how do we find the integrating factor? So the integrating factor involves p, and p in this case is negative 4. The integrating factor is e raised integral p dx, which would give us e raised integral negative 4 dx. And if we integrate it, we will have e raised negative 4x, and that would be the integrating factor. So the solution to the DE, mind you, this is not for y2, this is not for u, this is for w. So w would equal to 1 over u integral mu g of x dx. And g of x here, well, I should probably call it f of x, because I've used g of x already. The right-hand side of the equation that we rewrote would be f of x. So 1 over e raised negative 4x. Oh, there is a constant here, don't forget that. Integral e raised negative 4x multiplied by 2 e raised 2x dx plus c. So w would equal to e raised 4x multiplied by integral 2 e raised negative 2x dx plus c times e raised positive 4x. If we integrate, we will have 2 e raised negative 2x dx plus c e raised 4x. And e raised 4x times 2 e raised negative 2x over negative 2 plus c times e raised 4x. Which would give us, the 2's would get cancelled. So we have negative e raised positive 2x plus c times e raised 8x. Just checking my work one more time. Okay. And that is the solution to w, but we've got to find the solution to w prime. So w prime would be negative e raised 2x times 2 plus c 8 e raised 8x. Excuse me. We need to find the solution to u. So how do we find u? We find u by integrating w. So integral negative e raised 2x plus c times e raised 8x times dx, which would give us negative e raised 2x divided by 2 plus c times e raised 8x divided by 8. And that would be u. So again, if we recall, u is simply y2 over y1, which is y2 equals u times y1. So I could write y2 as u that I found, plus c times e raised 8x over 8 multiplied by e raised negative 2x, that is y1. So if I combine, I have minus 1 over 2 plus c times e raised 6x over 8. And since we already have multiple constants, when we do the integrating factor over here, we could set this constant equal to 0. So if we set that equal to 0, we can do that here in reduction of order. So if c is 0, u would simply be equal to negative 1 over 2. So, excuse me, y2 would be equal to negative 1 over 2. And that particular solution is free of arbitrary parameters, which is why we set that c equal to 0, because we don't want any arbitrary parameters. So that would become the particular solution. So we know the solution, the general solution, which is right here. And we know the particular solution, which is negative half. Therefore, the solution to the non-homogeneous equation is y equals negative 1/2 plus c1 e raised negative 2x plus c2 e raised positive 2x over 4. And that is the final solution. So here is a non-homogeneous equation. The right-hand side is actually a function of x, not just a constant. So to solve, we have one solution, which is y1. So we're going to make use of the associated homogeneous equation, which would be y double prime minus 4y prime plus 3y equals 0. And now we know how to solve that. So first we'll use reduction of order. y2 is y1 integral e raised negative p dx divided by y1 squared dx. y1 is e raised x. P is negative 4, so we would have e raised positive 4 dx divided by e raised 2x dx. And that is e raised x integral e raised 4x divided by e raised 2x dx. And that is going to give us, e raised x integral e raised 3x dx. Sorry, 2x. When we integrate, we have e raised 2x divided by 2. We will get e raised 3x divided by 2. So the general solution y equals c1 y1 plus c2 y2, c1 e raised x plus c2 e raised 3x divided by 2. And that is the first part of the solution. So the general solution. We want to find the particular solution. So if we recall, y2 is u times y1. y1 in this case is e raised x. And if y1 would satisfy the homogeneous equation, y2 will also satisfy the homogeneous equation. So we have to find y2 prime, which is u e raised x plus e raised x u prime. And y2 double prime is u e raised x u prime plus e raised x u double prime plus e raised x u prime. That's just the use of product rule. And I'm going to combine the terms and write it as 2 e raised x u prime plus e raised x u double prime. Now we plug in y2 prime and y2 double prime in the original DE. So we would have u e raised x plus 2 e raised x u prime plus e raised x u double prime minus 4 u e raised x u prime, and it is plus 3 u e raised x equals x. That is because y2 is u e raised x. So if we distribute and simplify, minus 4u e raised x minus 4 e raised x u prime plus 3u e raised x would equal x. Combining that term, and that term, they would all cancel. And if we combine, so we would have e raised x u double prime. And if I combine that term and that term, I would get minus 2 e raised x u prime equals x. We have e raised x in common, so u double prime minus u prime would equal x. Dividing by e raised x on both sides, we have x e raised minus x. Now the objective is to convert this second order dE to a first order dE. So let w equals u prime. This would imply w prime is u double prime. So I could rewrite, oh, I forgot the 2. 2. I could rewrite the equation as w prime minus 2w equals x e raised negative x. Unfortunately, this is not a separable equation, so we've got to use an integrating factor to find the solution. So p here is negative 2, which should imply the integrating factor mu is e raised integral p dx, which is e raised integral negative 2 dx. And if we integrate it, we have e raised negative 2x. And the solution for w, because we have rewritten the equation from u to w, is w equals 1 over mu integral mu times f of x dx. What is f of x? F of x is the function on the right hand side. So we have 1 over e raised minus 2x integral e raised minus 2x times x e raised minus x and dx. What should I do? Okay. So that is going to give me w equals e raised to x integral x e raised minus 3x dx. How do we integrate this? We could use integration by parts. If I set u as x, dv as e raised minus 3x dx, that would imply du is dx, and v is negative 1 over 3 e raised minus 3x. So using the formula for integration by parts, uv, so negative x over 3 e raised negative 3x, minus v du, minus 1 over 3 e raised minus 3x multiplied by dx. So we have e raised to x, negative x over 3 e raised minus 3x, plus 1 over 3 multiplied by e raised minus 3x divided by minus 3. Distribute the e raised to x, we would have negative x over 3 e raised negative 3x minus 1 over 9, e raised negative x minus 1 over 9 e raised negative x. And mind you, that is the solution for w, which is simply u prime. And we want the solution for u. So integrate on both sides. So we have integral of u prime equals integral negative x over 3 e raised minus x dx minus integral 1 over 9 e raised minus x dx. Again, using integration by parts for the first integral, we would have integral, I can pull the negative out, pull negative 1 over 3 out, x e raised negative x dx. If I set u, maybe I should use a different letter. If I set r equals s, x, and ds is equal to e raised negative x dx, dr is dx, and s is negative e raised negative x. So using integration by parts, we have rs, so negative x e raised negative x, minus integral s times dr, so negative e raised negative x times dx, which would give me negative x e raised negative x plus the integral of e raised negative x dx, which is negative e raised x. So the first part of the integral, I could have negative 1 over 3 multiplied by this expression. And the second part of the integral, if I integrate it, I'd get 1 over 9 e raised negative x. So by simplification, we would have u as 1 over 3 x e raised negative x plus 1 over 3 e raised negative x plus 1 over 9 e raised negative x. Combine the last two terms, we would have 4 over 9 e raised negative x. But recall, y2 is u times y1. And we are trying to find the particular solution for y2. So I'm going to multiply u by y1, which is e raised x. If I distribute it, I'd have x over 3 plus 4 over 9. I'm distributing e raised x inside. So that would be the particular solution. So the final solution would be the sum of the general solution, which we found earlier, and that is right over here. So the sum of the general solution plus the particular solution, which is right there. Do not forget, for a non-homogeneous equation, the solution is the sum of the general solution and the particular solution, and that's what we have.